Now let us understand the methods of purification of organic compounds. See, it's a very important method. We need to understand that how we normally separates out a particular organic compound from the mixture of the organic substances. Once we separate that compound, what we do is we do its elemental analysis, which is called qualitative analysis, and in which we try to find out what is exactly is a composition, which all are the elements which are present in that organic compound. And after doing that, we do its quantitative analysis, in what percentage those elements are present in that compound. So that what we can do is we can find out the empirical formula of the compound, and then by finding out its molecular mass, we can move on to what conclusion of its molecular formula. From where we go to structure elucidation methods, where we exactly tries to find out what exactly is the structure of that particular organic compound is. So this is the first step in this whole complete long process, and it's very important in the sense that we have to separate that particular organic compound from the rest of the other compounds, which we'll be calling as impurities. Now, these methods which we use to purify these organic compounds depends upon are employed according to the properties of the compound. The first in the list is the sublimation method. In this sublimation method, it is mainly used for those organic compounds which actually directly changes from solid to gaseous state. That means they sublimizes. So when the impure mixture is heated, the pure compound actually sublimizes out, and then it is being separated, and then it is being condensed to form the original compound, pure organic compound. And when we do, suppose we have very close compounds which also show this kind of a behavior, repeated sublimations can be done in order to get the compound in the purest form. So that is what is mainly for those compounds which sublimizes. The next method is crystallization. We all know crystallization, the process of forming the crystals from the saturated solution is called crystallization. What we do is the impure mixture is dissolved in a particular solvent in which all the organic compound is basically soluble. And what we find is that impurities either are insoluble or are less soluble. So what happens is their saturated solution is prepared and it is kept out. And then what happens is, when they are kept overnight, the main organic compound gets crystallized out, and it is being filtered out, and the mother liquor, what happens is, contains all the impurities, and the pure substance crystallizes out easily. Now what we need to remember in this method is that the solvent which we are taking for dissolving that particular impure organic substances, it should be like this, that the organic compound which we want to separate out should be less soluble in that solvent, not completely, so that it is not crystallizing out easily. So once it is less soluble, comparatively less soluble, it can be crystallized out much more easily. And if we have, suppose, impurities which are almost having very comparable solubilities, then what we do is we repeat this crystallization methods number of times in order to get the pure organic compound. The next method in the purification of the organic compounds is distillation method. We all know distillation, it's a process of separating two miscible liquids, which differs in their boiling point. It's a very normal, usual technique in which what we do is we take the miscible liquids, we heat them in such a way that what happens is one of the components is having a higher boiling point, the other one is having a lower boiling point. So the solution is heated in such a way that we are heating it at a temperature which is in between the boiling points of the two liquids, so that what happens is the more volatile one, the one which is having its lower boiling point, becomes what changes into its vapor state, gets separated out, and by using the condenser which is having running water, due to which its vapors easily gets condensed, it is being separated out, and the one which is having its higher boiling point or which is less volatile remains in this round bottom flask to which we are heating. So what we normally do is that this basic technique is mainly used for those liquids which are miscible, having different boiling points, and what happens is we know that always the vapor state is more rich in more volatile component. So the one which is having a lower boiling point, more volatile, gets easily being separated out, and the one which is having lesser volatile or having higher boiling point remains in this flask. And the best example to understand this one is the separation of chloroform and aniline. The chloroform and aniline, then they can be easily separated out because chloroform is having a lower boiling point than aniline, so it gets easily separated out on the other side after heating them above or around the boiling point of this chloroform, whereas the aniline remains as such in this round bottom flask. Then what we do, we have modified this distillation method according to our requirement. Suppose we are not having the miscible or a liquid which is not having two substances. It's having more than two. We call it like, let's take an example of a crude oil. Or we can have a mixture of substances or liquids which are actually more or less miscible, but they are more than two. Then in that case what we do is, or they are having very close boiling points, so that it becomes very difficult to separate them by this method. Now in that case we use another type of distillation which is called fractional distillation. Now in this what we do is, what we do in this case is that we add a fraction here before letting the fumes of the one of the more volatile component getting condensed and then separated out. What we do is we let these fumes to pass through this sort of a column. It is like this. It is like this. And then we heat it. Now, and this is called fractional column. Now, this fractional column increases the surface area. Now, what happens is, less volatile liquids whose vapors are there in this region, they get easily condensed here only. And the one which is most volatile gets easily being separated out. There's a very simple representation by a diagram of the fractional distillation. Though we know that it's more modified, and the higher version form is what we find in the refineries, where what we do is we separate the components at every level because they are having very close boiling points, and at the end, at the top, we have the one which is having the least boiling point, is most volatile, and at the bottom what happens is those substances are left out which are having the highest boiling points and are least volatile. So this is how we can separate the mixture of liquids where we find the components in that liquid are more than two exactly. So this is how they can be easily separated out, and the one which is most volatile gets separated out and other remains as such. And slowly by increasing the temperature, once that most volatile is being separated out, we can increase the further temperature, and then we can have another liquid being separated out, and this is how we can go ahead with this process, and we can separate those mixture of different liquids. Then we have another type of distillation which is called distillation under pressure. Now, distillation under pressure. Now, in distillation under pressure, it is mainly used for separating those liquids, or it's mainly used for separating that particular organic liquid, which decomposes on heating and specifically near its boiling point. So the problem is this: we cannot let that substance to be heated to its boiling point, because at that temperature it decomposes. Or what we are having is, suppose we are having two liquids A and B. One of them is less volatile, another one is definitely more volatile. But when we heat it, what happens is the less volatile, near about the more volatile, the less volatile one gets decomposed. So what we do is that we reduces the pressure. So once this pressure is being reduced, what we do is, in this case, a vacuum pump is being connected from this side. Now this vacuum pump, what does this vacuum pump does is, this vacuum pump reduces the pressure in this flask. Once this pressure is being reduced, you know that what is boiling point is the temperature at which the vapor pressure becomes equal to the atmospheric pressure. Now this vessel is closed, and once by the vacuum pump the pressure is being reduced, that more volatile substance which gets decomposed near its boiling point starts getting boiling point at a much lower temperature, and its vapor state becomes much more rich in its vapors that are easily being condensed out and being separated out. The best example of this one is separating glycerol from the soap. We know that glycerol is having a very high boiling point, but what happens is the soap, when heated up to the boiling point of the glycerol, what will happen is the soap will decompose. We don't want the soap to get decomposed, but we also want the glycerol to be separated out, which is there after saponification process. How to do it? What we do is we reduces the boiling point of the glycerol by reducing the pressure, so that before the soap gets melt down, what happens? The glycerol is being separated out very easily by distillation under pressure. That's one technique. We also do distillation by one more method, which is called steam distillation. We call it steam distillation. Now this distillation is done basically for those substances which are steam volatile, which gets easily being carried away with the steam, or with what we can say steam. Everybody knows the water vapors, heated water vapors. So what happens is, exactly what we do in this is that the steam is being introduced also along the side, like here. From here, the steam is being introduced into this flask. Now, once the steam is introduced into this, what happens is the total pressure of the more volatile component plus the steam's volatile vapor pressure. So the P of the component plus P of the water vapor total together makes the vapor pressure of the substance much higher, and that is what we find is that particular substance starts boiling much below its normal boiling point. So this technique is mainly used for separating out those substances which are not stable at their boiling points and which can easily be carried away by the steam. So steam from the other components remains as such in the mixture. So what happens is, by just letting the steam pass through those mixtures, what happens that the total vapor pressure becomes much more higher, and that is how they get easily being separated out, and later on they can be easily separated from water by different methods. Now the best example for this one is separation of aniline from water. Yes, we can separate aniline, this one, from water. So this is an example of the separation of the aniline from water by steam distillation, where this aniline is easily being carried away by the steam. The next method of separating the organic compound is differential extraction. It is used when we find that the compound is soluble it is present in water, it is present in the aqueous medium, and it is to be taken out from that aqueous medium. So what we do is we use a special type of a funnel, which is called separating funnel, which is almost like this. Now in this, what we do is we take that aqueous solution, which is there of water, and we add a suitable organic solvent into it. This is the organic solvent we have added. Like we can use ether or acetone or any other organic solvent, CCl4, carbon disulfide, etc. And this is the aqueous solution of organic compound. Now what happens is, after taking this aqueous solution of organic compound in this separating funnel and then adding organic solvent, this whole separating funnel is shaken vigorously, so that what happens is the organic substance actually comes out of this aqueous medium and gets dissolved in the organic solvent, because this organic compound is more soluble in organic. This organic is in its own organic solvent. So like dissolves like. So since this organic compound is more soluble in organic solvent, when it is being mixed, whole of the organic compounds comes out of this aqueous medium and it moves into the organic solvent, and then we let these two layers of the organic solvent and the water settle down. What happens is, we know that they will form two separate layers, and after opening this top cork, we can easily separate the two layers, and this is how we can easily take out organic compound from its aqueous solution. So this kind of a method is mainly used for extracting the organic compounds on the basis of the difference in their solubilities in aqueous and in organic medium. Now the next method of separating the organic compound from the impurities, or the purification method, is called chromatography. It's a very important technique of separating the components of a mixture of organic compounds by the differential movement on a stationary phase with the help of mobile phase. Now this chromatography technique has been given name from a word called chroma, which means colored substances. So basically it was initially used to separate the colored substances. Now the chromatography, mainly on the basis of the techniques, different techniques used for this process, are of two types. One is called the adsorption chromatography, and the second is called partition chromatography. Now, as the name indicates, of course, the basic technique of the chromatography is the adsorption capabilities. The substance which gets adsorbed first gets separated out first, and the substance which gets adsorbed later on gets separated out later on. And this is how we can separate the different components of a mixture, and we can also find out how many components are there in any particular mixture. Now, if the mobile phase and stationary phase are together, it's called adsorption, and if they are separated, it's called partition. Now, let us understand these one by one. Additional chromatography again is of two types. It's of two types called column chromatography and other is called thin layer chromatography. Now, what is this column chromatography? In column chromatography, we use a long column tube which is almost as like a burette. We fill a silica gel into this, and then what we do is, with the help of the silica gel's paste in a suitable solvent is added to this chromatography column. And then what we do is we add the mixture of the components above this, and then again the same suitable solvent is being added. Now what happens is the solvent take these different mixture or the different compounds which are there in the mixture along with them and move downward. And now what happens is the one which is having the higher adsorption capabilities gets adsorbed first on the silica gel, and the one which is having the lower one gets also separated out or moved down along with the solvent, and they gets adsorbed later on. So now on adding more and more of a solvent, we can let these move along with them, and slowly what happens is different zones or layers or different of colors are formed, which actually are indicating that how many components are there in that mixture. And on keep on adding that solvent, we can actually extract these different components, colored components, or which we can easily we can separate, or we can easily find out that okay, they can be demarcated from one another, they can be separated out from this column. So this is what is called column chromatography. In this, what we find is the stationary phase silica gel and the mobile phase the solvent are moving together. They are there together, and the components are being separated on the basis of their differential adsorption. Then this is what is called column chromatography. Now what is then thin layer chromatographies? In this, what we do is we put a thin layer of the silica gel paste on a glass sheet, and then what we do is we load a component or a mixture on it by putting a line, and then we we just make this glass tube to stand on in a special flask which is called chromatography jar, and then the small end of this glass tube is actually immersed in a suitable solvent. Now what happens in this case is that what we find is that due to the adsorption capabilities, this solvent will rise in this, and along with this what we find is this component gets dissolved in this the moment the solvent is rising, and different spots are being generated. Now from the number of spots, we can easily make out that how many components are there in this column in this given mixture, and then we can find out the distance traveled by the, suppose solvent moves up to this side, and then we find that there were only 2 spots. So this is the distance traveled by the component X from the baseline, and this is the distance traveled by the solvent from the baseline Y. And in order to differentiate the differential movement of the different components, we have introduced a term in this which is called retardation factor or retention factor, which is called RF. It is called a retardation factor. Now it is actually X by Y, distance traveled by the component from the baseline over the distance traveled by the solvent from the baseline. It tells us the different differential movement of the components on the basis of the on their adsorption capabilities. So this is what we have, adsorption chromatography. Now the next type of chromatography is partition chromatography. As I have told you, in this what we will find is the stationary phase and mobile phase will be separated. Now in this we use a special type of paper which is called a chromatography paper, which is actually a pure cellulose paper. Its strip is being taken and the mixture is loaded on it with the help of a capillary. Then it is hanged in a jar which is called chromatography jar, and this paper is actually dipped. Its lower portion is being dipped in a suitable solvent, and this is what we have usually, which is usually either is a petroleum ether or acetone water mixture or an ether water mixture. Then what happens is we let this paper get hanged in this chromatography jar. Now due to this, what happens is capillary action, the solvent rises above and it moves along with the component, and what we get spots like this. And once we find that no more spotting is coming up, we can stop this, we can take out this chromatography paper, and then we can find out the distance traveled by the solvent and the distance traveled by the component. We can find out their retardation factor, and on the basis of this, what we can find out, that we can know that how many components were there in that mixture, and by cutting then these papers and then letting them dissolve in a suitable solvent, we can separate the components of the mixture also.